Welcome back to the stage of computer science history. I'm going to show you a couple things. We're going to go back in time a little bit, and I'm going to go over one of the fun sheets we did, and also the lab from last class, which I need to tell you some stuff so you're able to do that thing that I asked you to do in the past. Let me tell my computer that I do not want to restart it right now. There we go. So this right here, if you remember, was the while loops fun sheet that you did a couple classes ago. And in this, what we wanted to do was throw flowers at all these nets until we get to the flower at the end. And we wanted to use a while loop to accomplish this. That would mean you don't have to write so much code. You just have to figure out what action is being repeated. What are we doing over and over again? And just write the code for that one action in the loop, and the loop will repeat that action until we reach some condition. So the code I have right here, if I run this right now, it creates a Giroux way up there in the corner, and the Giroux starts with 6 flowers because that's the constructor I use. And you can see here that there are 6 flowers that this Giroux has. And that's all it does because we haven't written any other code. So we want to solve this problem using a while loop. But before that, let's just try to solve one step. What am I repeating? Well, there's 6 nets. And so I have to throw my flower at a net and take a step forward so I can throw my flower at a net and step forward, throw my flower at a net and step forward. So if I did this without a while loop, I would do something like this. Tom.toss, because that's the method that tosses a flower, and then tom.hop. So if I run this, we toss a flower, which gets the net, and then we hop forward into that space. And then there's another net, so I have to toss a flower and hop again. So I would copy and paste this, Control-C copy, and paste 3, 4, 5, 6. And then if I ran this, tell it to just go forward. See, he's going to throw and hop until he gets there. And then, okay, we want one more hop maybe so he can get on top of the flower. Tom.hop. Rewind that. Play that again. So now he's going to go. He keeps tossing and hopping and tossing and hopping. And then he hops. He's on the flower. Great. He's done. But look at all this code I rewrote. We don't like that. So we look for a pattern. What's repeating? Well, toss, hop, toss, hop, toss, hop. I see I'm repeating that toss, hop all the time. I know that because I copied it and pasted it a whole bunch of times. So I must be repeating it. So let's get rid of all of this except for the thing that's repeating. If I want to do this over and over again, I just put it in a loop. While, and then inside the loop's curly braces, I write, I want to toss and hop. But I have to tell it when I want to toss and hop. I have to put a condition in here. I want to toss and hop while some condition is true. So there's a couple I could put in here. I'm going to start with, let me rewind this so we can look at the map. I want to toss and hop as long as there's a net in front of my Giroux. That's an easy thing to think about. So I can say Tom, while Tom is net ahead, so while there's a net ahead of Tom, he's going to toss a flower at it and hop forward. So now if I run this, he's going to just keep doing this over and over and over again. And then he stops before the flower. So I could add in a hop at the end, just like I did before. Tom.hop. And I could run this again. And now he's going to toss and hop, toss and hop. And then at the very end, once the loop's done, he'll do this last hop and he ends up on the flower. So that works. There's another condition I could put in here. It uses a tool we haven't learned yet, a tool we're about to learn, maybe next class. Instead of saying while there's a net ahead, we're going to instead make a condition based on the flower. The flower is kind of like our goal. It's our finish line. So I want to keep throwing flowers at nets while I'm not at the finish line. So I'm at the finish line if there is a flower. So Tom.isFlower here. Okay, so if Tom is standing on top of a flower, he's at the finish line. But I don't want to say that. I don't want to say while he's at the finish line. I want to say while he's not at the finish line. So we're going to use a tool that we're going to learn more about in a little bit. But if you put an exclamation mark before the condition, so that's a little exclamation mark, this basically means not. So while not Tom is flower here, while there is not a flower where Tom is standing, then I want to toss and hop. So if I run this, it's going to do approximately the same thing. If he's not standing on a flower, he's going to toss and hop. And so he ends up in this last step. Let me rewind that and do that a little slower. He's doing all this stuff. He's in the while loop. So we check, is Tom standing on a flower? No. Is he not standing on a flower? Yes. Tom is not standing on a flower. So he tosses and he hops. Is Tom standing on a flower? No. But the while loop's asking, is Tom not standing on a flower? Yes. Tom is not standing on a flower. So he's going to toss. He doesn't have a flower, so he just tosses nothing, and then he hops. Boom. Now he's on the flower. Is Tom not on a flower? No, Tom is not on a flower. And so now our loop is done, and our program is done. Okay, so this is another way you could write this while loop, which is saying while I'm not done yet, and I know I'm done when I'm on a flower, then keep doing this thing. That's not what I expected you to write in this lab. Of course, the expectation for this lab was while Tom dot is net ahead. This is what you were expected to write for this lab. But I just wanted to show you that there's this alternative, and that's going to turn up again in a second. So this is what while loops do. I want to point out one more thing, and this is important. At the end of the while loop header, right here, I'm going to put a little arrow there. There's no semicolon. I did not put a semicolon there. If you put a semicolon here, then this code is not going to work. It's going to run forever and not do anything. Like you won't see anything happen. It'll kind of crash your tab. So no semicolons at the end of your while loop headers. Also, if you have an if statement, you do not put a semicolon at the end of the if statement. Another thing I want to say about this, I don't think so. I think I got notes here. I think that's all I got in my notes for that. So while loops, repeats code. Look for it when you're copying and pasting or you see a pattern that you want to repeat. Put that in a loop instead of writing it over and over and over again. All right, so now I want to talk about Lab 4.1. So Lab 4.1 starts off pretty simple. We got to put a Drew way down here in the corner. So he's going to start, let's say, at 23.0. So we make Drew May equals new Drew. I say it was 23. I'm gonna look again. I just hover over it and it tells me right below where I'm hovering. 23, 0. So for this lab, look at the instructions. This is our starting condition, and we want to use a while loop to make our Drew hop all the way over till he's on the flower. So it's pretty simple, but you don't want to just hard code hop, 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 or even count them out and say hop 17 or whatever. We want to write a loop to do this step by step. And so this is where, so what are we repeating? We want to repeat may.hop. May.hop. We want to do this over and over and over again. And so yeah, you could count 1, 2, 3, 4, 5, like say like may.hop, I don't know, 16. And when I run that, he just appears, boom, way over there. And I could do that, but that's not what we want to do for this lab. We want him to hop one space at a time. So we're just going to do a regular hop, but we want to repeat it, which means we have to put it inside of a while loop. While something is true, I want to hop. I want May to hop. Okay. So what's the condition that goes in here? This is where we want to think of this as, as our finish line. While I'm not at the flower, hop forward. Okay, so this is a pattern. It's a technique you use to solve this kind of a question. While I'm not where I'm going, try to get closer. So while I'm not, exclamation mark, at the flower, while the flower is not here where May is. May dot is flower here. So while May is not on top of the flower, hop. And so I hit play. I hit rewind first. I hit play. And so As long as he's not on top of the flower, he's going to hop forward. And then as soon as he ends up on top of the flower, that condition will no longer be true, and the loop stops and our program stops. Okay, so that's what we were looking for the first part of 4.1. But then, I want to open that. We want to open up. So all of this, we're writing code. The code we write should solve all of these maps. So we should be able to go back and forth and solve all these maps. I'm not writing new code for all of them. I'm going to add code, but this code will always solve the previous maps. So now we've got this big old hurdle here that we want to get over. And it's made out of nets. So I'm just going to add, I guess I could just I'll just open it. Rewind. File. Try that again. Rewind, island, file, open. Hurdle 2. So now we've got these nets. So now if I run my code, he's going to hop forward, hop forward, hop forward, and then, oh no, he dies, okay? This loop would get me to the flower if there weren't those nets in the way. What I need to do is I need to protect my Giroux. I don't want to hop forward if there's a net ahead of the Giroux. I need to turn so that it's safe, okay? So I'm going to add code. And this is what we're doing to solve all the rest of these kinds of problems, is to add code, if statements to the while loop to keep the Giroux safe. So I'm going to check for a condition where he's not safe and change his state so he is safe. So I'm not safe if there's a net in front of me. If may.isNet ahead, if there's a net ahead of my Giroux, then I need to make it so the net's not ahead of my Giroux. So I want to turn so I'm no longer facing the net. May.turn. I'm going to look at this and pretend I'm the Giroux. If I'm facing the net, I want to turn to my left. So may.turn left. So now I'm going to step through this so we can see how this goes. Let me rewind. Oh, I have an error maybe? Oh no, oh, here we go. We make the Giroux. So there's my Giroux. And we're going to, is he on the flower? No. So the loop's going to go. Is there a net ahead? No. So we're going to skip the body of the loop and just hop. And this is going to repeat a couple times. Is he at the flower? No. Is there a net ahead? No. Skip, hop. And so this keeps going, hopping, 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 until now, is he on the flower? No. Is there a net ahead? Yes. So now we're going to run the body of this if statement, and we're going to turn left. Now there is not a net ahead of my Giroux, and I can hop. And then we're going to get in that same situation where I hop and hop and hop and hop. But oh no, what's going to happen if I just hit play on this? He just keeps going in this direction. Eventually he's going to just run into that water, and that's going to be a bad deal. So we need to add some more code into this that will check to see, should I turn back going the other direction, right? So at what point, let me run this again. Get it up. And I'm going to pause. So when the Giroux is here, we actually want the Giroux to turn. So he comes back across this hurdle. So we need to add another if statement. Because right now, all we're checking is if there's a net ahead of him, he'll turn, and then he'll hop. But we don't want to hop here. We actually want to turn again, right? So we need another if statement. If something, oh, I have to rewind it. If something is true, then I want may to turn, T-U-R-N, and he's going to turn to his right. Fix the spacing here a little bit. So what has to be true? What condition do I have to look at when the Giroux is standing in this spot right here facing up? How do I know the difference between him here and say him down here that he should turn to the right? What's the difference between all of these spots and this spot? Okay, so think about that. What do you think I should put in that if condition? I like where you're going. So we want to check that there's not a net right here. So I'm going to say if may dot is net right. Actually, then we have to say not. We can put not, but there's actually probably a better way, right? An easier way is we don't care whether it's a net or not. We actually want to just check if it's clear, right? Can I step to my right? So I can say if may dot is clear, because that's one of my methods, to the right, then I want to turn right. So all of these spots, it's not clear. There's a net. And then all of a sudden, boom, it's clear. So let's turn, and then we'll be able to move that way. So let's see what happens here. If I run this, he hops across till he gets the net. He turns. He comes all the way up. And then when he gets to a clear spot, turns again. He's going forwards. He turns again. That's pretty magic. That's exactly what we want to happen because he hit a clear spot. So he turned, and then he ran directly into the water. So that's a bummer. We need to make it so before he hit into the water, what did we really want to do? We really wanted him to turn again so we could go this way, right? And he wants to turn to his left. So we can think about that in terms of if statements and just add another if statement. If there is water ahead of the Drew, if is water ahead, then what do we need to do? We need to turn left, semicolon. So I've added, for each one of these cases, right, I just added an if statement. If there's a net ahead, turn left. If it's clear to your right, turn to the right. If there's water ahead, turn left. And let's try playing this. He hits the net, he turns, he keeps going forward until it's clear on his right. Once it's clear on the right, he'll turn, keeps going forward until again it's clear on the right. He turns, keeps going forward now until there's water in front. Boom, turn left. And now it's going to keep going until it gets to the flower. And once he gets to the flower, he stops because the while loop stops because that was the condition. And now, so that solves this map. Let's open up the next map. I have to rewind again. Hurdle 3. So this has some different shaped and sizes hurdles, multiple hurdles. Let's just see where we are with this code. With the code we had, I didn't change anything. It's the same code we had last time. So he gets around this hurdle. Awesome. And then he's getting around this hurdle so far. Goes over the top. Great. And oh, that was weird. He didn't go all the way down that hurdle. So that's maybe something we have to think about. How can we solve that problem? And he's coming down. This guy, we can speed this up a little bit. There he goes. And then he goes up over that one. Great. And then he stops in the flower before he gets to the water and dies. That is exactly what we wanted to happen. Now, there was some bug happened here, right? He came across, and instead of coming down and back up, he came across and just went straight up. So what's the difference? It worked. He worked here, and he worked here, but it didn't work here. So what's the difference between these two spots where it worked and this spot where it didn't quite work? So if you can identify the difference, that can maybe help you figure out what you have to do to solve that problem. How can we change this code to solve that problem? So there's a problem there that we need to fix. And then let's see about the fourth map. So I'm going to just see if it works on this map. He goes around that first hurdle. That's good. He's going to come up around this hurdle. And he ended on the flower. Cool. So it works for this map. So the only bug we have right now in our code is in the third map. We got to figure out how to solve that. And I'm going to leave that up to you to get that solved. So basically, we're reducing this entire lab into just map 3. Make sure this code works. Should work for all of the maps. Specifically, though, it needs to work for map 3. And we have to fix this bug. Now, another way to think about this problem is we could break it into methods. So you can go into Drew methods and write a bunch of methods. So another way we could think about this is maybe instead of all of this stuff, I'm going to write the ideas of the methods here, and then you might want to implement those methods and figure out how to implement them using while loops. So while you're not at the flower, we're keeping that. We're going to say may dot go to next hurdle. So this method, when you call this, your Drew would hop until he gets to a hurdle. Okay. And then he would maybe in turn to face up. So this would make Drew hop to next hurdle and turn left. So he's facing up. So that would tell me I want to go to the next hurdle, and then I want to may dot go up hurdle. And so go up hurdle would make him go, he's gotten to a hurdle, he's going to go up the hurdle, and when he gets to the end of the hurdle, he's going to turn. But that's it. He's just going to go up and turn. Go up and turn when at top of hurdle. And then you can make another one, may dot go over hurdle. And for this method, if you're already at the top, this one just moves you across and then turns so you're facing down. So this is go across and turn to face down. And then once you're facing down, you want to come all the way down the hurdle and turn to face to the next one. So you would want may dot go down hurdle. So by breaking, all I did, I haven't done anything really. I'm making up method names right now, but I'm breaking this problem down into steps in English that makes sense. So what am I doing? So what are we doing? While I'm not at the flower, while I haven't finished yet, what am I going to do? I'm going to go to the next hurdle. I'm going to go up it. I'm going to go over it. And I'm going to go down it. And then what am I going to do? I'm going to go to the next hurdle again. I'm going to go up it. I'm going to go down it. And I'm going to go to the next hurdle. And I'm going to keep going to the next hurdle, going up, over, and down until I have reached the flower and I'm all done. And so this last one here, go down hurdle, will go down hurdle and turn left. So you want to make sure these methods set themselves up for the next method in that chain. So you're always facing the direction you would want to be facing there. So by breaking the problem down into these smaller problems, I can just worry about solving the smaller problems. So I can go and I can comment out for now. I would even comment out the while loop just for testing purposes. And I can write this method, go to next hurdle. So I go to methods, method, go to next hurdle. And then in here, I would write code that would just get my Drew from where he is to the next hurdle. So I have to identify, so I know I want to hop. How long do I want to hop? I want to hop while there isn't a hurdle in front of me, right? Maybe while it's clear in front of me, I'm going to hop. While is clear ahead, hop. And so Drew's just going to hop forward. When you say go to next hurdle, you'll hop forward until he reaches the next hurdle. And then we can test this because I put comments in front of all of these other lines. The only line that's going to run is this one right here. So if I run this, just hit run. Oh, I have an error. Oh, I have to spell it correctly. I have to spell it the same way in both places. Hurdle and double check Hurdle. So you gotta make sure those methods are spelled the same way. So now when I run it, it's hard to see in this one. I'm actually going to change. I'm going to change the island file back to the second one. Yeah, so this one, he's going to start way over here, and he should just go to the next hurdle. He should get to the next hurdle. So I hit run, and there he goes. Boom, I had it real fast. Let's slow that down. Not that much. Rewind, play. So he goes to this method. He's going to hop as long as it's clear. Once it's no longer clear, he's reached the hurdle. But of course, for this method, I said I want to hop to the next hurdle and then turn left. So I really want to update this method so that once that while loop's done, I turn left. And of course, remember when I'm writing a method, I don't use a Drew name. You just say hop and turn, because in the main method, when I say May go to next hurdle, May is the Drew that's doing all of this stuff. So I know in here, I'm checking if May is clear. I'm telling May to hop. I'm telling May to turn. So now that I've added that one line of code, I'm going to run it again. He comes over here. Once he reaches the hurdle, he stops and turns. And now he's set up for me to write this method. So I can just delete those comments and now go write my go up hurdle method. I'm not going to do that. I want you to follow this process. And this is going to set you up for success for this hurdle problem. Talked about semicolons. I got that. So that's it. That's what I want to talk about. So what we're going to do is we're going to work on finishing this lab, and then I've written you some new labs. I say this in the past tense, but I'm about to write you some new labs. So 4.3, 4.4, 4.5, and then you're going to come back to this one and you're going to finish this one. Okay, that's what I want you to do. They're gonna progress back into this one. So it's kind of like a step-by-step guide there. So that's what you're gonna work on, those labs, and let me know if you have any questions, and I'll help you out. But I think this while loop technique is the secret you needed. This was the secret sauce. And breaking it down into methods like this, solving the problem step by step, is going to help a lot, I think. Let me know if you have questions on this, and rock and roll. Computer science.